Hello everyone. I welcome you all to the e-videos prepared for Anna University syllabus under the Regulation 2021. Today we are going to see the video session on the topic process concept and the second unit process management in the course CS 3451 Introduction to Operating System. Let me introduce myself. Dr. C. Rani, Associate Professor from the Department of Computer Science and Engineering, Government College of Engineering, Bodi Naikanur. The objective of today's session is to know about the basic concepts of what is meant by process and threads. The outcome of this session, the students may be able to understand the basic concepts of processes and threads. Let's have an overlook on today's session. That is, first we are going to discuss about the introduction of process concept and how the process works. And let us discuss the structure of process in memory. Next, we'll be discussing the process states using a state diagram, the process control block, which is PCB. And next, we'll be discussing about thread and what are the difference between process and thread. Next, we'll see about process. What is meant by a process? Which is defined as basically a program in execution. So as we know all, program is nothing but a piece of code written using text editor. So the program is not in a running state. Okay. If you are executing the program, we call it as a process. The program in execution, we call that as a process. So the execution of a process must progress in a sequential fashion. So the process is not same as that of the program code. We call process as the active entity. Since we are executing the program, we call that as an active entity. And program is considered to be a passive entity. So the attributes held by process, which includes the hardware state, memory, and CPU, etc. Okay, the program becomes a process when an executable file is loaded into the memory by two ways. By double-clicking an icon representing the executable file or entering the name of the executable file on the command line. So we can process by either way to load the file into the memory. A system consists of a collection of processes. So operating system processes the executing system code and the user processes the executing user code. All these processes can execute concurrently with the processor. And we can also go by switching the processor, that is CPU, between the processes also. That we call it as the context switch technique by means of a technique called context switch technique. So in that manner, we can also go by increasing the CPU utilization or the processor utilization, thereby reducing the response time also. Next, we can see how the process works. When we start executing the program, the processor begins to process the program by using the following steps. First, the program will be loaded into the computer's memory in the form of a binary code after the translation. A program requires memory for storing and other operating system resources to run the program. The resources such as registers, program counter, and a stack, and these resources are provided by the operating system. A register can have an instruction, storage address, and other data that is required by the process. The program counter will be maintaining the track of the program sequence. So the stack has the information on the active subroutine of a computer program. So a program may have different instances of it, and each copy or the instance of the running program is known as the individual process. Here we can see the structure of the process which is stored in a memory. Here the process is otherwise called as job or task. The process is more than a program code. So we'll be writing the piece of code, that is the program code, in the text section. So the structure of process includes text section, data section, heap section, and start section. In this text section, we'll be writing the program code. And the process also includes the data section, which contains the global variables. And the process also includes the heap section, which is memory, which is dynamically allocated during the process runtime. And this process also have the stack section, which contains the temporary data such as function parameters, return addresses, and local variables. The program counter and the contents of the processor registers are also present in the structure of the process. Next, we'll be seeing about the states of the process. Whenever the process starts executing the program, it changes its states from one type of state to another state. The state of a process is defined in the part by the current activity of that process. Each process may be in one of the following states: new state, running state, waiting state, ready state, and terminated. There are 5 states in the process. Okay. So whenever the process is newly created, the process is being created, then we call that as the process is in new state. When the instructions of the program are being executed, we call that as the process is in running state. When the process is waiting for some event to occur, for example, the event such as an IO completion, IO input output operation need to be completed, or the process can wait for receiving the signal. Then we call that process is in waiting state. If the process is waiting to be assigned to a processor, that is CPU, we call that the process as in the ready state. Okay. The process, when the process has finished all of the execution of the program, then we call it as the process is in terminated state. So these are the 5 states. Each process may be in one of the following states. So here you can see the process, 5 states of process using a state diagram. So when the process is newly created or being created, it is in the new state. The process is in the new state and it is admitted to the ready state. So from the ready state, the processor or the scheduler dispatches to the running state. Here, when the process is in running state, the program will be in executed. The program will be starts executing the codes, program code. So at this running state, when the process is in the running state, it can move from running to terminate state, that is first case. And the second case, from the running state, it can move to the waiting state. And third case is from the running state, it can move to the ready state. So from the running state, the process can move to 3 cases. Okay. If all its program has been completed execution, the process will move from the running state to the terminated state. Okay, that is the exit of the program. Okay, next, second case, whenever the process is in the running state, where it goes to the waiting, that is, it is waiting for the any of the input output operation need to be completed or any event to occur. It will wait for any event to occur. So from running state, the process will reach us the waiting state. After the IO operation is completed, or any event is completed, from the waiting state, it will move to the ready state. And again, the cycle goes on from ready to running state. Okay. So this is your second case. Then the third case is from the running state, when the process, an interrupt occurs during the execution of the program, from the running state, the process will reach as the ready state. Okay. So these are the process will change from one state to another state. Using the state diagram, we have seen this. Next, we are going to discuss about the process control block. So each process is represented by the process control block, that is PCB, which is also called as task control block. So this PCB structure contains the process states that just now we have seen the 5 states of the process, that is new state, running state, waiting state, terminated state. Okay. And second one is program counter, then CPU registers, then CPU scheduling information, then memory management information, then accounting information, and IO status information. So these are all the information which will be maintained in a process control block, that is otherwise called as task control block. Okay, we'll see one by one. The process states may be in 5 states, that is new state, ready state, running, waiting, and terminated state. Then the program counter indicates the address of the next instruction to be executed for the process. And the CPU registers may vary in number and the type depending upon the computer architecture. The CPU registers include accumulators, index registers, stack pointers, general purpose registers, plus any condition code information. So along with the program counter, the state information must be saved when an interrupt occurs. So always when an interrupt occurs, all these informations will be stored or saved in the process control block. Allow the process to be continued correctly after the state has been interrupt is over. So it has whatever the information stored in the process control block, it will be continued. The next information is CPU scheduling information, which includes the process priority information will be stored there, and what are all the pointers to the scheduling queues, that information will be stored in this, and any other scheduling parameter information is also stored in the CPU scheduling information. And memory management information may include the value of the base registers and limit registers at the page tables or the segment tables, depending on the memory system used by the operating system. So the accounting information includes the amount of CPU, time limits, account numbers, job numbers or process numbers, and so on. IO status information includes the list of IO devices allocated to the process, a list of open files, and so on. Next, we'll see about threads. So thread is nothing but we call that as a lightweight process. That is, when the process is running a word processor program, a single thread of instruction is being executed. So the user cannot simultaneously type the character, and if you want to check the spell, we need to run the spell checker within the same process. For example, a process may contain multiple threads and execute. So thread is nothing but it will be executing a task, more than one task at a time. So this feature is especially beneficial on the multi-core system where the multiple threads can run parallelly. On a system that supports threads, the PCB, that is process control block, is expanded to include all the information for each thread in the PCB. Okay, here you can see the process is nothing but the program and execution. where the thread is nothing but the unit of execution within a process. So the thread, a process will be containing multiple number of threads inside the process. Here you can see the process which contains number of threads from thread 1 to thread n, and each thread is going to perform a task, number of tasks. We call that is a multi-threading process. Okay. Next, we'll see about the difference between the process and the thread. So the process is we call it as a heavy weight or resource intensive, and thread is lightweight, taking lesser amount of resources than a process. The process switching needs interaction with the operating system. Thread switching does not need to interact with the operating system. Okay. In multiprocessing environments, each process executes the same code, but it has its own memory and file resources also. All threads can share the same set of open files child processes. If one process is blocked, then no other process can execute until the first process is unblocked. While one thread is blocked and waiting, a second thread in the same task can run. That is the more advantage. Okay? Multiple processes without using threads use more resources. Multiple threaded processes use only a fewer number of resources. In multiple processes, each process operates independently of the other processes. One thread can read, write, or change another thread's data. So here we can see the advantage of thread. So thread is going to minimize the context switching time. That is, context switching is a technique where we can switch the processes, switch the CPU, that is processor time among the processes. Thereby we can increase the CPU utilization. Okay, the use of threads will also provide the concurrency within the process, and it also provides the efficient communication among the processes. It is also economical to create the threads and use the context switching techniques. Okay. Thread also allow the utilization of the multiprocessor architecture to great scale and efficiency. Here you can see the window task manager having the number of application. Using the application tab, we can see three number of programs are being running, that is in the running status. That is Word document is being running, and thread, that is Chrome browser, is also running. So when we move on to the next processes tab, here you can have the collection of what are all the processes are involved in a application. Okay, here you can see number of processes are being stored in the applications, image name, that is username, and what are all the CPU and what is the memory utilized for each and every process is also described here. And if you want to move on, what are all the threads involved in this processes? For that purpose, you can go on with installing and downloading the Process Explorer. Can be downloaded and installed in your desktop. There you can find what are all the threads involved in the process. Okay. Here is the threads informations in each process. You can see it here. So each thread includes the information transaction ID, CPU, cycles delta information, starting address information. So these are all the informations maintained for each thread in a process. These are the references used for preparing the slides. Thanks for watching. Thank you.